Hi everyone, welcome back. Today we'll be working with standard 6.ns.b4. Use a distributive property to express a sum of two whole numbers 1 to 100 with a common factor as a multiple of a sum of two whole numbers with no common factor. So this is the second part of our distributive property lesson. The first one we did no variables. For this one we will include some variables. So what is a variable, you may ask? A variable is any letter in the alphabet used to represent an unknown number. So most frequently you'll see the letter X, but it can be A, B, C, D, so on all the way to Z. An expression. An expression is a mathematical sentence that does not include an equal sign. So whenever we have expressions, we simplify them, we bring them down to a smaller set of numbers. When we have equations, we solve them. So an equation is a mathematical sentence that includes an equal sign. Like terms. So like terms are terms that are separated by addition or subtraction that have the same variable and the same exponent. So again, they have the same variable and the same exponent. So an example of that would be if I have 2 plus 3. So 2 plus 3, so 2 is a term, 3 is a term. Okay, constants are like terms. So both of these are like terms. And what that means is I can combine them and make them simpler. So 2 plus 3 would be equal to 5. However, what if I had x, which represents a variable, plus 7? X is a variable, 7 is a constant. These are not like terms. This would be like saying I have apples and bananas. Okay? I can't add apples to bananas and say appananas. I would have to say, oh, I have 3 apples and I have 3 bananas. Yes, they're part of the fruit family, but we look at them as individual items and they are not like terms. So the same thing here. X plus 7, X is a term, 7 is a term, but they're not like term. What about if I have X plus X squared? Now they both are using the same variable, but they have a different exponent. So X just sitting here by itself is like saying X to the first power, and then X squared, we have an exponent of 2. The difference in the exponents make them unlike terms. So we can't do anything further with them. Now, what if I had just x plus x? Here, they are the same term, right? So it's the same variable, same exponent. These are like terms. And I can combine this by saying 2x. So x plus x would give me 2x. So based on what we just discussed, let's take a look at these other examples. Now, whenever I'm working with my like terms, I like to use shapes, so circles, squares, so on and so forth, just to identify the terms that are similar. So when I look at the first example, I see x plus y plus z plus z. Now, x is one term, y is another term, z is another term, and z is another term. Now let's take a look at them. X is by itself. I don't see any other X's. Y is by itself. However, I do see my Z repeating. And when I circle my like terms, I include my sign. And we'll talk more about this when we get to integers. So this is a positive Z and a positive Z. So when I combine those together, it gives me 2Z. And then I rewrite whatever is left. So X plus Y. Okay. Now I cannot combine anything else because they're unlike terms. So my X could be apples, my Y could be grapes, my Z could be oranges. I can't combine them. They're different types of fruits. Now let's take a look at the second example. So the same idea. I'm looking for same variable, same exponent. So here I have 2x, which whenever there's not a sign in front of a number, we know it's positive. And then I have positive 4x. And then I have a positive 3x to the second power. So this exponent of 2 makes this an unlike term because the exponent here is 1 and the exponent here is 1. So when I simplify that, I get 6x plus 3x squared. I can't do anything further. I've simplified it, and that's as much as I can do. Now let's take a look at the third example. So in my previous definition, it said that constants were like term. So remember I talked about needing to circle the sign with the number? So this is a -2, and this is a +5. Now my y's are different terms because there's an exponent here and there is none here. Okay, so now I have y minus 2 plus 5 plus y squared. Now 5 minus 2 is 3. So if I have 5 things and I give away 2 of them, I have 3 left. So y plus 3 plus y squared would be my final answer. I don't need to solve it any further. I don't need to do anything because I do not know what the value of these variables represent. I just combined my like terms. All right, so let's just do this quick activity to identify some like terms. I'm going to use my color and just shade in boxes that are similar, okay? So constants involve our negative and positive numbers. So if I were to go through this chart, I would say -48, +8, +6, 1/2, all of those are like terms, okay? Now let's take a look at another one. So I have 2y squared. That's a like term. Do you see any other? Yep, 9y squared, 1/4 y squared. So it doesn't matter what the coefficient is, the number in the front. All that matters is that it's the same variable and the same exponent. So that's what I see for now as it relates to y squared. Let's take a look at 7x squared. So I see 7x squared here, 2x squared here, -15x squared here, so on and so forth. So you guys can take your time and finish up this table, x squared here, right? And just try to figure out, okay, what are the other like terms? Okay, so I see 5y here, another y here, 7y, okay, -3y, yep. All of those are like terms. Same variable, same exponents. Okay, 3x, 8x, -5x. I guess I'm having so much fun doing this that I don't want to stop. So 2x, I think I got those. I had missed the x squared here, so -x squared. Let's just go ahead and finish this up since I'm already so far into it. 4x to the third, 2x to the third, -3x to the third, 8x to the third. All right, so those are the like terms. So any boxes that contain the same color are considered like terms. So let's get back into our distributive property. So that was our combining like terms, which is just important to know that whenever you see, like if you apply distributive property and you see that there are terms that are similar, you can combine those and simplify the problem further. So here we know that to distribute means to multiply the number or value on the outside of the parentheses to everything that's on the inside. So we're going to draw those arrows. Okay, you want to always be in the habit of doing so because it's a visual reminder that that 8 needs to be multiplied to the x and the 8 also needs to be multiplied to the 4. Now we're going to rewrite this as the sum. So there's addition here. So it's going to be sum or difference if it was subtraction. So now I have 8 times x, and I have 8 times 4. So in one of my earlier videos, I talked about using the dot, the big dot, or just parentheses to represent multiplication, because once we start using x to represent variable, we don't want to confuse ourselves. So whenever you have a number next to a parentheses like this, that denotes multiplication. So this is reading 8 times x plus 8 times 4. Then step 3, if it asks us to multiply, then you want to go ahead and do that. So 8 times x is just going to be 8x. I can get rid of that parentheses. 8 times 4 is 32. Now I cannot simplify this any further. These are unlike terms. There's a variable here, and this is just a constant. I cannot combine those two terms. So this would be my final answer. Let's try a few more examples. This is a good place to pause and try this first one on your own and then restart. So let's go ahead and apply the distributive property as instructed. So this is now 7 times A plus, my A looks a little bit like a 9, so let me fix that, plus 7 times 2. And if I simplify this further, I get 7A. So I'm just eliminating that parentheses. And then here I'm actually multiplying. Plus 7 times 2 is 14. And that's my final answer for that problem. I cannot do anything further. So let's take a look at another example. Before I start this example, I want to change this minus with my 11 to a plus. Okay, so this is a plus 11. Now I'm going to apply my distributive property. So instead of having 2 terms, I now have 3 terms. So 3 times D, and I'm going to just rewrite that with my parentheses so that we see the steps, plus 3 times 11, plus 3 times 3. And now I can go ahead and simplify. So 3 times D is just 3D. 3 times 11 is 33. And then 3 times 3 is 9. Now, if you remember from earlier in this video, we talked about like terms. And like terms, constants are like terms. So I have a positive 33 and a positive 9. Those two numbers are in the same category. So what that means is that I can add them. So I'm going to finalize my answer. The 3D is going to carry over. And then 33 plus 9 is 42. So I'm going to do plus 42. And that would be my final answer. Okay? Now let's take a look at the third example. So again, I'm drawing my arrows to show my distribution. And then I'm going to apply my distributive property. So 5 times 8G minus 5 times F. And then we just go ahead and simplify. So 5 times 8 is 40. So when we talk about like terms, it doesn't apply to multiplication and division. We can multiply the 5 times the 8. We just can't add or subtract on like terms. So 5 times 8 is 40G. And then minus 5 times F, which is just 5F. And that would be our answer. So 40G minus 5F would be our final answer. So let's take a look at this example. It says, given the following rectangle, write an expression that represents the area. So first you have to remind yourself, what is the formula for finding the area of a rectangle? So the formula for finding the area of a rectangle is A equals length times width. And we can say that this here represents our length. So we'll say 6 is our length and x plus 10 is our width. And we can go ahead and plug those in. So A equals 6. And I'm going to write that 6 in parentheses. And then I'm going to write the x plus 10. So if you remember, I said that parentheses denotes multiplication. So I don't have to write anything else. Okay. Now, based on what we've learned, the fact that we have this number on the outside, okay, I can actually rewrite this as 6 times x plus 10, and then I can clearly see my distribution. So I'm going to distribute the 6 through to the 10 and the 6 through to the x. Okay, so now I can rewrite this as 6 times x plus 6 times 10. 6 times x is just 6x. 6 times 10 is 60. Okay, and here we do have units. The units are feet. So we're going to just go ahead and write feet squared because that's what we know for area. So the final answer here is just 6x plus 60 feet squared. I cannot do anything further. That is my final answer. All right, let's take a look at this example. It says, which expression does not belong? So which one does not belong? With the other three, explain your reasoning. So if I take a look at this first one, I definitely see distributive property. right? There's a 2 next to the parentheses that's being multiplied. If I look at the second one, I also see distributive property. Now, if I look at this one, there looks like there's a little bit of switching around, right? So my multiplication is happening inside the parentheses, and then on the outside, we're being added. So I cannot distribute this 4 through to the x or the 4 because that's not distribution, it's addition. So what this would actually look like is that I would multiply x times 4 to give me 4x, and then I would just bring down the 4. Over here, I do see multiplication again, the 8, and then there's a parentheses. That tells me I need to multiply. So 8 times 9, 8 times a minus x. So which one does not belong? It would be this one here. And the reason is that it's showing addition instead of distribution. Okay, in order to be distribution, the number on the outside of the parentheses would need to be multiplied through to the values inside the parentheses. Okay, thank you for watching and have a wonderful day.